All right, so the page number is off on this one. It's actually, oh no, it's not, it's page 44. I was just reading it wrong. So we're gonna look at page 44 real quick before we start looking at our next piece of like the card sorting thing. So, oh my gosh, screen? Seriously. So what we're going to be doing is we are going to try and find a linear equation. So we're going to write another equation for each of these situations. We want to write another equation where we wind up with one solution. We want to write another equation where we could possibly wind up with two solutions. And I have on another page the other two situations. No solution and infinitely many solutions. So if we have this equation here, what do we need to do to be able to find another line? Oh my gosh, why are you so blinky? I hate that so much. I hate that so much. It's blinking. Hey, blinking. Stop. What can we do with this equation to maybe help us find some information about it? If we have 5x minus 2y equals 3. Do I know much about that line when it's in this form? Not really. What could I do if I wanted to know more about this line? Let's try putting it in slope-intercept form and see what we see. So what do we need to do to put this in slope-intercept form? Yeah. Let's subtract 5x from both sides. And I'm going to, on this side, put it in front of the 3. So we're going to have minus 2y equals minus 5x plus 3. Then what are we going to do? Oh, thank you, sir. Yeah, if we divide everything by that -2, we're on page 44, Marianne. 44? Yeah. All right. So if we divide everything by -2, that lets us get this into slope-intercept form, which is sometimes more helpful when we're trying to find things in relationship. So we have our y equals, well, if we look at this, -5 over -2, yeah, you can have 2.5x or we can do 5 over 2x, but the negative signs cancel out, and we have minus 3/2. Gross! But that's what we have. They're just jerks because they give us a gross equation. So we could graph this if we wanted to, if we're feeling real froggy. We could put this, we've got our y-intercept. We know it's going to start at -3/2. So somewhere down here. And it's going to go up 5 over 2, up 5 over 2. So we're going to get a line that looks something like that. It's not going to let me have a nice tidy line. And I'm just giving us a little sketch of it. Not super nice, but just so we can think about what we would need to get one solution. What do we need in order to get one solution?
We need x and y.
I was like, we're writing an equation for something that's going to give me one solution with this. Yeah, something that intersects it. It could be here, could be here, Could be there. Could be could be anywhere. Pretty much almost any line, except for what kind of line?
Oh, parallel.
Except a parallel line. That's the only line that's not good. Why are you so blinky? Seriously? Stop it. Ma'am, pull yourself together. Loose. Maybe. Stay. Okay, so as long as it's not a parallel line. Do we remember how we can tell a parallel line from an equation? What do they have the same? The slope. So as long as it has a different slope, we'll be good. So for one solution, I need any line that has a different slope. So you guys get to write an equation. Any line that has a different slope. So something like y equals, somebody give me a slope that's not 5/2. 1x. Give me a y-intercept. Plus 6. That is a line that will give us one solution. I'm not saying it's going to be a nice solution, but it gives one solution. Also would work 1/2 x minus 12. 300x minus 4 million. Pi x plus 2. Like, you can pick anything. Anything that's not 5/2x. Anything. Creative freedom. I just need a line that's gonna cross it somewhere. That gives me one solution. All right, we're still thinking about linear equations. So we're talking linear equations here, right? Can I take a line and get two solutions with the black line here?
Would they have to stack on top of each other?
But is this two solutions?
No.
What is that called when they're stacked right on top of each other? Infinitely many. So I can get infinitely many solutions. I could have no solutions. I could have one solution.
What about,
Can I have two?
what if the line is horizontal? No, didn't know.
What would it need to look like for us to have two solutions? A U. It would need to be a parabola. Is a parabola a line?
No.
No. We'll deal with parabolas next chapter. Preview. So it would need to be something kind of U-shaped or curved in some way, shape, or form. So two solutions is not possible with only lines. If we were not subjected to linear equations, we would have a vast variety of choices. I could do a circle. I could do an oval. I could put a circle on here. Circle. It hits twice. I could put a U. I could put square roots in certain places. I could put exponentials. But I cannot do it with just a line. If I'm using a ruler, I can't make it cross twice until I curve it. Okay? So we cannot have two solutions with a system of linear equations. So let's think about our other two situations. Those are the words. Other two situations. So our no solutions, we already kind of talked about that a little bit. When do we have no solution? Say it again.
When there are no intersections.
when there's no intercepts. So what does it need to have that is the same as this one? Or remember our slope-intercept form was our y equals 5/2 x minus 3/2. What does a no solution equation need to have? No intercepts. Same slope. I'm gonna say intersection just because I can't. They need to be parallel, which means same slope. So it needs to have the 5/2. So we need to have our 5/2x. Can it have the same intercept to be parallel? Or does it need to be different? So let's think about it. If I have the same slope and the same y-intercept, so same slope locks it here. If I have the same y-intercept, is that parallel? Or are they right on top of each other? So if they have the same slope and the same y-intercept, how many solutions do they got? Because they're stuck. Right on top. Infinite. So if I need them to be parallel, I need to yank that off of it. So can it have the same y-intercept and be parallel? No. They need to have different y-intercepts. Same slope, different intercept. So when we're looking for a parallel line, I need it to have the same slope, but a different number here. You could leave it like this. You could do +0. You could do 5/2 x plus 1,000. Parallel. Really far away, but parallel. As long as it's not minus 3/2, you have a parallel line. For our infinitely many solutions, what does that need to have? Infinitely many solutions means what's the relationship between the two lines? They're stacked, right? It's the same line. So we need the same slope and the same intercept. Okay? So these are our three real options for here, plus one that they tried to trick you with. We can have one solution, we can have no solution, or we can have an infinite number of solutions. The infinite number of solutions means they are the same line. Usually written either with a multiplier, so like on this one, the 5x minus 2y equals 3, if I said 10x minus 4y equals 6, I just multiplied everybody by 2. It'll give me the same answers, but it looks different. Usually we're trying to give you one that looks different. I don't care if you write me 100% exactly the same line. It's still the same line. So if it was me, what I would say for our same line, different intercept, when they give us this, oh look, we wrote it. It's in a different form. Y equals 5/2x minus 3/2. There's our infinitely many solutions equation. Okay? So, same slope, same intercept. It is the same line. They are stacked. We gave you the same line twice because we're being extra. Shock of all shocks, right? Me? Extra? What? Who? I don't know her. Okay, but there's a question like this on one of the homework assignments. I don't remember which one it is. It may even be the exact same equation. But it's kind of awkward to try and figure out on your own necessarily what I'm looking for. So I don't want the question to be, what are you trying to figure out my brain? I want you to figure out the math. Ma'am. The gremlin is in here now. Oh my gosh, just saying. All right, so we're doing the group thingy. Yay! We're on pick your partners, and I double checked our attendance didn't actually affect any group, so we should be good. Yay! As part of that, because it's through Google Slides, and Google tries to help. Google helps. So it does frequently autocorrect the names. I can fix that. Yeah, Google thinks it's helping when I very intentionally try and type things in right. And it goes, clearly you didn't do that right. Yeah. I'm gonna fix it. All right, so get with your partner, because we are going to start this today. Get with your partner or partners. Oh, sorry. I'm trying to fix it. There we go. Boop. Yeah. What's up? Yeah, give me a second. There we go. There we go. I fixed it. All right. What's up? The cards? I haven't had them out yet. Because it's a little different. It's not laminated. Y'all gonna have to do some cutting. Oh, snap. All right. So what we're gonna do is you're gonna sit by your partner. And we're gonna talk through something real quick before I pass these out. It says grab a dry erase marker because I used to have you guys write on your desks. I don't have enough. I don't have enough stickies on the desks. So we're gonna think about it this way. You can grab scratch paper or whatever. If I gave you an equation like this, y equals 3x plus 2, and I said, if x equals 5, what does y equal? What would you do? Substitute it in. Y equals 3 times 5 plus 2. Right? Yes, it'll be 17 because 3 times 5 is 15 plus 2 gives you 17. If y equals 8, what would we do? 8 equals 3 times x plus 2. Subtract the 2. So we get 6 equals 3x. X equals 2, right? Okay, so what we have on our cards for today and tomorrow, you're going to get a table, a graph, and an equation. Often you will not get all three because you need to fill them in. Okay, so you're going to get 6. You'll have 6. There's 2 on each page. So you're going to need to cut them out. You're going to need to cut them apart. And then tomorrow, we're going to connect them up. So you need to make sure that your graphs, equations, and tables are good. That's what the partners are for, so y'all can check each other's stuff. Okay? So, I need y'all to properly see it so I don't give groups more than one thing. Okay? Nope, hadn't written it yet. Okay, so I'm going to pass out cards. 2, 8, 2, 1. There you go. And I'm going to keep all the arrows and I'll give you guys a wish tomorrow. All right. In the blood there. Boop. Good. Right here. Nice and easy because you guys are Declan just walked out. Marquez is in the black cover.
The white shirt underneath?
Okay, raise your hand. Right there. So you should get 6 graphs that you need to fill in. Diane's over here, and Ian, and you probably want to see something. You get 3. Those are yours. You get those 3 pages. You get, it's 6 graphs. It's 6 separate pieces here. Yeah, so you're gonna eventually cut them apart. There you go. And you guys have that, and you guys need that. 1, 2, 3. Arrows. Oh. So you're only grabbing 1 line on each correct right now. Okay, you just go back and put it back.
Okay, we can do it like this?
Yeah. Okay. Does everybody have their 3 pages with their 6 graphs?
I got it. Yeah. I died.
Because what we're eventually going to do is we're going to make a big poster that connects all of these with how they interact. There we go. I fixed it. Google will no longer change your name. I fixed it.